Hi, for today's topic, I will teach you how to classify conic sections. But first, let me give you the definition of a conic section. A conic section is a curve formed by intersecting cone with a plane, and there are four types of conic sections, namely circle, ellipse, parabola, and hyperbola. So I will give you the definition of each and how do we derive each conic section on a cone. The circle is made from a plane intersecting a cone parallel to its base. So meaning to say, if this is your base, when you slice your cone parallel to the base, you will have or you can derive a circle out of it. If it's an ellipse, it is made from a plane intersecting a cone at an angle to its base. So given an angle here, so if you see this section, it will form an ellipse. The parabola is made from a plane intersecting a cone at an angle parallel to the slant edge. Slant edge is this side. So meaning, if you slice your cone parallel to the slant edge, you will have a parabola. And lastly, the hyperbola is made from a plane intersecting both halves of a double cone but not passing through the apex. This part is the apex. So when you slice your double cone, here, for example, you will have here what you called the hyperbola. Okay. Let's proceed with classifying conics using their equations. Any conic can be described by a general second degree equation in x and y. The general equation would be ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. The expression b squared minus 4ac is the discriminant of the equation and can be used to identify the type of conic. So in here, the most important parts that you have to identify is the ax squared, bxy, and cy squared because the numerical coefficients of this term is very important for you to be able to solve for the discriminant. So here are the conditions on the discriminant. If the value of your discriminant is less than 0, and b is equal to 0, and a is equal to c, then it's a circle. When we say less than 0, those values are negative. Next, if your discriminant is negative or less than 0, but either b is not equal to 0 or a is not equal to c, then it's an ellipse. So don't be confused. Both circle and ellipse have negative discriminant. The only difference is that the value of A and C are equal at circle and ellipse, it's not. For the parabola, your discriminant is equal to 0. So that's a parabola. And lastly, hyperbola is greater than 0. Greater than 0, that is positive. So take note, if B is equal to 0, each axis of the conic is horizontal or vertical. So how do we identify the four conic sections in equation form even without identifying the discriminant? So if it is a circle, x and y are both squared and the coefficients on them are the same, including the sign. For example, we have 3x squared minus 12x plus 3y squared is equal to 2. As you can notice, we have the x squared term and the y squared term. So from the definition given, when x and y are both squared and the coefficients on them are the same, meaning to say, we are focusing with or we are recognizing the conic section which is a circle. So if you would like to check, you can also use the discriminant in identifying which type of conic section is this or if you want to prove is if this is a circle. So in here, a is equal to 3 because that's the number beside x squared. B is equal to 0 since you don't have the xy term. And c is equal to 3 also because that's the numerical coefficient of y squared. As you can notice, a is equal to c. If we will go back, in circle a is equal to c. Other than that, you can check if this is correct through the use of the discriminant. So again, the formula for the discriminant is b squared minus 4ac. So just substitute. So this will be 0 squared minus 4 times 3 times 3. And if you simplify this, that equals to negative 36. So since this is negative, we rule out that this one is a circle. Next example would be a parabola. So even without solving for the discriminant, we will know that the equation is a parabola if you only have one squared term. For example, y is equal to x squared minus 4. As you can notice, we only have one squared term here. Y is equal to x squared minus 4. So in here, a is equal to 1 since the numerical coefficient of x squared is 1. B is equal to 0 since you don't have the xy term. And c is equal to 0 since you don't have the y squared term. If you use the discriminant, b squared minus 4ac, it should be 0 to prove that this is a parabola. So let's substitute. So this will be 0 squared minus 4 times a, which is 1, times c, which is 0. And that equals to 0. So meaning equals to x squared minus 4 is a parabola. Next would be x is equal to 2y squared minus 3y plus 10. So let's identify the parts. A is equal to 0 since you don't have the x squared term. B is equal to 0 since you don't have the xy term. And C is equal to 2 because that's the numerical coefficient of y squared. So let's use the discriminant to check if your discriminant will be 0. So this will be 0 squared minus 4 times 0 times 2, and that equals 0. So meaning to say, these both equations are both parabola. Next would be ellipse. So for ellipse, x and y are both squared and the coefficients are positive but different. So meaning to say in here, a is not equal to c, but the signs should be both positive. So let's try to check. In here, a is 3. That's the numerical coefficient of x squared. B is equal to 0 since we don't have the term xy. And c is equal to 2. It's because the number beside y squared is 2. The only clue here is if it's a, that's the number beside x squared. If it's b, that's the number beside xy. And if it's c, that's the number beside y squared. So let's check the discriminant. So if it's an ellipse, the discriminant should be negative. So let's substitute. So 0 squared minus 4ac, and that equals negative 24. So that's negative, meaning to say we are dealing with an ellipse. And lastly, for the hyperbola. When x and y are both squared and exactly one of the coefficients is negative and exactly one of the coefficients is positive. So for the equation for y squared minus 10y minus 3x squared is equal to 12, it is an example of a hyperbola. This time, the coefficients of x squared and y squared are different, but exactly one of them is negative and one is positive, which is a requirement for the equation to be the graph of a hyperbola. So let's identify what's A, B, and C. So in here, A would be this part, including the sign, that's the number beside x squared, which is negative 3. In here, B is 0, you don't have the xy term, and C is equal to 4, because that's the number beside y squared. Then, in here, as you can see, A is not equal to C, but you have opposite signs. If that's the case, you will rule out with a hyperbola. To check if this is correct, let's have the discriminant. So the discriminant of a hyperbola should be positive. So let's try to use the values here. So this will be 0 squared minus 4 times negative 3 times positive 4. And that would be equal to positive 12 because negative 4 times 2 is positive 12 times 4. And that equals positive 48. Meaning to say, we rule out with a hyperbola. Let's have additional examples. So in here, we have 9x squared minus 25y squared minus 18x minus 100y minus 316 is equal to 0. So in here, a is 9, as you can see, b is 0, c is negative 25. So a is not equal to c. Also, they have opposite signs. One is positive and one is negative. So meaning this is a hyperbola. The next example shows y squared plus 6y minus 4x plus 1 is equal to 0. As you can notice, you only have one squared term, which is y squared. So meaning, this is an example of a parabola. Next example. So in here, we have 9x squared and 25y squared. So meaning, a is equal to 9, b is 0, c is 25. So as you can see, A is not equal to C, but they are both positive. So in here, we have an ellipse. And lastly, we have x squared plus y squared plus x is equal to 0. So as you can see, the values of A and C are equal, which is A is equal to 1, B is equal to 2, C is equal to 1. A is equal to C. So in here, obviously, we roll out with a circle. So that would be all for our lesson for today, which is all about classifying conic section. I hope you learned from me. So thanks for watching and please don't forget to subscribe. Thank you. Bye.